So our solution was what we call the institutional knowledge graph. We're going to build this foundational semantic layer that we hoped we could build upon to solve other issues, other problems. So we actually implemented the institutional knowledge graph. Everything in green here, this funky green, we have succeeded. We call these the data domains that we wanted to go after. So we wanted to find out a lot about the people, organizations, locations, the work that's being done, the different projects, and the key roles of the people that work on those projects, the milestones. So we've been pretty successful pulling that data together. Of course, we don't consider these domains complete, but as we find more sources, we will keep augmenting that information. And we have two areas that we have on our list that we haven't addressed yet, which is there are a lot of applications around the lab that people use. There are a lot of different repositories, content repositories. We want to get that into the graph so people can find them, find out about them. We also want to get documents, and not documents themselves, but the metadata about documents and publications, so we can start tying people to expertise. So we're still working on that. And we just recently implemented something we call the IKG history graph. IKG itself is basically, here is a snapshot of what's current. So here are all the people and what their current positions and where they fit in the organization. But we want to capture those changes as well. So anytime we observe a change, we write it to the history graph. And we've just been doing that for maybe a month or so now. And so we're hoping that over time you could look back to see, well, who are all the project managers on Voyager, for instance, which has been flying for 50 years, et cetera. You could look back in time and see what those changes were. So now we have our institutional knowledge graph. It's been in place for a couple years now, I believe. So now we're starting to see, we have what we call an Enterprise Semantic Platform. So we have the tools that we use are our ontology and taxonomy editor and manager, and we have our RDF graph database application. So we have that platform. But mostly at first, IKG was its main customer. But now we're starting to see our expanding semantic verse. And just so you know, this is a picture from the James Webb Space Telescope, which I think is just phenomenal. JPL doesn't manage this project, but it did make the mid-infrared instrument. So that's how JPL is involved, but I just love this picture. So now our semantic pyramid has a filled-in layer now of our organizations and people and projects and facilities, which continually grows. You know, I think every 3 to 6 months we have another release. We add more data as we find more data sources. I think as we talk to more people, they start pointing us to, it's like, well, you can get information from this system that we didn't know about. So we keep pulling in more and more information. And then, of course, we have our model or our ontology that we try not to be very strict, or we try and make it so it's very adaptable to, aggregation. And but we do use unique identifiers for institutional concepts that we're going to talk about in detail a little later. So now that we've laid this foundation, domain-specific knowledge graphs can build upon it, and we're starting to see that now. But not only knowledge graphs, but also taxonomies and other semantic data sets. So I got the institutional knowledge graph here in the center. And let's say, just say that we have a person over here and we know where they fit in the organization, where they sit, their education, we know a lot of information about them. These semantic data sets, and some of them are taxonomies, like the science taxonomy, the JPL taxonomy, which is just now being built up. Even though it's been a dream for a decade or whatever to have one, it never has materialized, but I think now we have some momentum behind it. Business event transactions, we have a knowledge graph of certain applications. We're gathering that data into a knowledge graph. Our master list of controlled records, the labs that I talked about, that are labs around the lab, where are they? So now we're able to, those semantic data sets are able to leverage the IKG for their people, organizations, et cetera. So they don't have to keep all that information in each one of these data sets. They can just leverage the IKG. And in going back the other way, we can then learn more about people because we have access to these data sets. So now we not only know where they sit in the organization, but we also can maybe find out more about their expertise and what they know and what they do, they actually do. Sometimes your job title does not really totally give you a context for what you're doing, specifically doing, which project you're specifically working on, and what role you have on that project. It may not be an institutional role, it might be internal to the project. So here's an example of what the IKG knows about people and buildings and rooms and organizations. So we know about those things. We might know what organization John Smith belongs to, for instance, and we know a lot of attributes about him. But what we can gain by pulling from these other data sets is the Robotics Lab now. There is a Robotics Lab, and so we now know who's responsible for it, who's accountable for it, where it's located, different rooms in different buildings. Sometimes they're spread out, but they're considered still one lab, and what organization's managing it. So now we have a lot more information about people and all of these entities. We know more about them now. You can put them. Here's another example, more complicated. This is the activity data set that I was talking about of either life cycle events. So a business object, let's say an inspection record, they're inspecting a part that's going to go on the spacecraft. It's going to go through a life cycle. And so every time it goes through another life cycle state, as it progresses through that life cycle, it sends a status event to this system. Then we capture that, and we also put it in a knowledge graph. And then when we leverage the IKG, so everything in the blue is coming from this activity data set, and everything in the red's coming from IKG, and the green is different taxonomies. So now if we link all these things together, then we can start making inferences about this person's expertise, where it fits in the, he knows a lot about robotics, which is in the technology discipline. We know his organization. We can also, we know what date this event happened, and so we can relate that to project milestones that were in the IKG. So now we can start really pulling all these puzzle pieces together to tell a story in case anyone wants to go back and say, what happened on this project? And so now I'm going to turn over to the details that Bess is going to give you.
Great. So Anne mentioned a few examples of what kind of data sets we've connected and what we can do with those, but we wanted to back up and just make it really explicit. Why bother connecting different data sets? What's the point? So the most obvious point is that you need to do this to answer complex questions. So if we have data from the institutional knowledge graph about people and organizations, and we have information from, say, our labs data set about labs, if you want to be able to ask a question about, which labs are in a building if the power goes out, and who do I need to contact about that, you really need to be able to combine those different data sets to answer questions and kind of follow the path to get to the data you need. On top of that, we found that connecting data sets is actually a really important tool for finding what we call data discrepancies. So you'll find information that conflicts and doesn't make sense. You'll find one fact in one data set, one fact in another, and we've actually found this to be a really powerful way to clean up data across JPL. So for example, we'll find buildings in one data set, then another data set says don't exist. We'll find people assigned to roles when they've actually retired from JPL. So combining these data sets really allows us to clean up some of that data. So now we're going to get into the technical nitty-gritty of how do you actually make these data sets talk to each other. So before we get started, just baseline assessment here, who knows what a URI is? Okay, like 50%, so we'll go with only a few of us. Back up a little bit here. So we're going to start with some RDF basics. Anne mentioned this is one of the W3C standards that we're using to build our knowledge graph. This is kind of the core standard. So we've been showing a lot of these bubble and line diagrams, but how do we actually encode this information in a way machines can understand it so that we can make these connections between data sets in a programmatic way? And the answer, of course, is the Resource Description Framework, or RDF. You'll hear people talk about this as things, not strings. It's the idea that everything gets an identifier, and those identifiers can be used across different data sets to connect them. So for example, if we have this one statement here that John Smith is accountable for the Robotics Lab, to be machine readable, we need all of our bubbles and lines to actually have unique identifiers, or what we call uniform resource identifiers, URIs. You might also hear this referred to as an IRI. They look like URLs, but they don't actually have to go anywhere. So if we were to look at this example again using URIs, you can see we've added a unique identifier for every bubble, every line, every relationship. So this is what makes this machine readable and what allows us to kind of connect John Smith in one data set to John Smith in another. Now this is machine readable. It's not very human readable. It's kind of ugly to look at. So one important concept here is the idea of prefixes or namespaces. So we can take that long, unwieldy URI, take kind of the front portion of it, give that a prefix or a kind of substitute name, and then rewrite this. So you can see that our big lab, Robotics Lab URI can be distilled down to just lab:"Robotics Lab. So it makes it both human readable and machine readable. Moderately human readable. This is hopefully easier to look at. So we're taking that same bubble line diagram, we're adding in URIs, but we're making it a little easy for humans to understand as well. So this idea of namespaces, the reason we're mentioning it, in addition to making URIs more readable, this has big implications for governance and ownership when you start connecting multiple data sets. So for example, if you have multiple data sets, you don't really have control, well, depends on your organization. Usually you don't have control over all the fields that an owner of a data set would use. So if Anne and I are building the institutional knowledge graph and we come up with some relationship called accountable for, we might have a very specific meaning for that relationship that is a very specific context, versus say our HR system might have a relationship accountable for, same field, but they might mean something totally different. So if we can use URIs and then give these URIs specific namespaces, it makes it very easy to tell who's defined this attribute or relationship or entity, who owns it, where is it coming from, and making sure that you're not conflating two different fields just because they have the same name. So these namespaces have been really crucial for helping us connect data sets and then kind of disconnect them when needed. So the reason we're spending so much time talking about URIs is because they're kind of the crucial piece to connecting these different data sets. So we want to build these URIs, and by reusing them across different data sets, we can ensure that we only need to define entities once. Whoever owns the data set or owns that entity gets to be the one who defines it, and everyone else pulls from them. Make sure that there's a clear owner. We know who owns this data, who created this entity. And the most important part, the reason we're talking about all of this, is that it makes it possible for semantic data sets to link to one another. So how do we actually do this? We've given everything URI, we have multiple data sets. How do you actually link those data sets together? Unfortunately, there's no one solution, so we've broken it down in a few different strategies we've used. So the ideal scenario is that you reuse URIs in different data sets. If we create a URI for John Smith in the institutional knowledge graph, everyone else reuses that same URI, so there's no confusion that John Smith in my data set is the same person as John Smith in your data set. Of course, that does not always happen. Another option, what we're calling our pretty good technique here, is that you match on what we like to call hooks. So these would be things that are institutionally recognized identifiers like usernames for people, maybe location identifiers for rooms, things like that, where you might have two different data sets using two different URIs, but you've got some kind of attribute you can use to say pretty confidently these are the same thing. Then we have our probable technique, which you could probably call educated guesses. You're not 100% sure, but it's better than nothing. And then there's always manual review is sometimes required. You need a human being to go in and look and say, yes, these are the same thing. So looking into those, our ideal scenario here, when we say we're reusing URIs, you can see if we have two data sets, dataset 1 and dataset 2, I've got person B. Schrader in dataset 1 where I've said this is a person and here's her name. And then in dataset 2, maybe I'm looking at documents and I say this document was created by person B. Schrader. Because I'm using that same URI in both cases, there's no confusion. We know this is the same person. So great. If we look at our pretty good scenario, same thing. Let's say we've got person B. Schrader in dataset 1, dataset 2, we've got a document, but we've used a different URI here to say, you know, this is created by a person. But we've got some kind of hook, like a username, where we've left that in both data sets, so we can say, all right, this person in dataset 1 with this URI, and this person in dataset 2 with this other URI, same person, probably. Then we get into our probable scenario, where we're kind of making educated guesses here. So in this case, we have to kind of come up with matching rules or algorithms to try to determine whether something's the same. So for example, I might say, all right, well, if we have the first initial and the last name matching between these two different data sets and we can connect the person to the same organization, it's probably a match. This gets a lot more complicated, takes a lot more maintenance. Not ideal, but sometimes it's your best bet. And if you have enough information, you can still make pretty good guesses about, you know, whether two things are the same in different data sets. And then finally, another example is just matching on labels. So going back to Anne's OCO2 example from the beginning, if we have two different data sets where we're talking about a project, we can maybe look and see are there any kind of combinations or matches between labels. And we do a lot of this with the institutional knowledge graph since we've spent some time kind of connecting or making this foundational layer of projects and people. And then finally, sometimes we have to do manual review. So in this very unlikely scenario, let's say we have two best Schraders. One is best P. Schrader, one is best X. Schrader. And we know that this document was created by just a B. Schrader. You might need a human being who can go in and say, you know what, I know something about KMWorld, and I know that the person going to KMWorld is best P. Schrader, so that's probably our match. Obviously, this is an incomplete data set because I did not make this presentation by myself and should also be in here, but hopefully this gets the point across. So we've used these data methods. You've started to figure out which URIs are the same, whether you're reusing the URI or using some kind of matching technique. What do you actually do with the data? So once you've made the connection, how do you get the data sets to talk to each other? And we use one of two methods usually. So one is you actually copy data between data sets at set intervals, and the other is that you leave the data in place and run federated queries across it. So for example, if we're copying data, let's say we've got our two data sets again, one where we define the person, one where we're looking at documents. I can just copy data from dataset 1 into dataset 2. So I pull in that definition that's occurring in dataset 1, so whoever's looking at dataset 2 gets the full benefit. Obviously, there are some implications here about synchronization. You have to set this up to run at set intervals or on set triggers to make sure that you're not having a lot of stale data in your second data set. You can also do this, if you're not reusing URIs, you can do this via those hooks. So one example of what we've done at the JPL is we've got our labs data set where a user can provide a username for an individual, and then it's at intervals. We then go back to the institutional knowledge graph and pull in all the information we know about that person. So you've got this kind of push-pull synchronization happening there. Federated queries, if you're familiar with federated queries in any kind of search system, it's kind of the same thing. You leave the two data sets alone, you leave data where it is, and then you run a query that accesses both of those data sets. So for example, if I wanted to know who created the KMWorld 2022 presentation, you would send that query to both of your data sets, and from data set 2, you'd find out it was created by person B. Schrader. From data set 1, you'd actually figure out the name of that person and return the result. So there are pros and cons to both of these. Copying data is faster. Well, it's faster for querying, not necessarily faster for moving data. And there's more integration options. You'll have some systems that can't support federated queries or applications that are not able to send queries to multiple systems. But sometimes when you combine these data sets, you get really big data sets that, that storage size might have some implications for certain tools. And it requires that synchronization techniques to make sure your data is staying up to date. Versus federated queries, it's really nice. You can separate out access permissions. So if you have a user who can access one data set but not another, you can make sure your queries respect that. And your queries are in real time, so you don't have to worry about synchronization and data getting stale. But your queries might be slower, more complex. Your integration options might be a little more limited. And with that, passing it back to Anne.
We'll be jumping up and down, back and forth. So now we have our institutional knowledge graph, and now we have new semantic data sets being built that are leveraging the IKG, and now we can start asking both simple, very simple, and complex questions. So we've been working with the enterprise search team so they can start leveraging the IKG information to provide to users who are using the internal portal to search for things. We also, there's another application called a facility search. Now the facility search application knows about, or before the IKG, they knew that a certain building and a certain room, they knew that this room, let's say 104, was a lab as opposed to a conference room or an office. But that's all they knew about it. It was just a lab. Now that they're leveraging the IKG, they can now know, the name of the lab, the organization that manages it, the associated people. And what's nice is they only have to come to the IKG. The IKG is aggregating this from several different data sets. So it looks like it should all come from one, but it doesn't. It comes from at least 3 different data sources. So you look back to our activity knowledge graph that I was talking about. So with this one, when you're when you're trying to do, you can answer more complex queries because now this is, these activities are associated with projects and people and organizations and topics and et cetera. There's a lot going on in that knowledge graph. So now we can use that federated query that Bess talked about to point to these 2 data sets and start asking, slicing and dicing across this information, which members of were active in quality assurance during this time, which mechanical engineers with experience on rover missions, because we have that data. We know exactly who was doing work, day to day in that data set. So what activities currently in progress involving robotics, et cetera. You can ask these very complex questions because you have these linked data sets. Oh, okay. I think we're pretty good. So now back to remember our ideal state of being able to ask natural language questions and get answers. We're now evaluating some tools that can leverage RDF graphs to do that very thing. So we're just getting started doing that. So I can, at the moment, ask who started at JPL in 1980, And there are other people besides me, but I am one of them. And that's when I became a JPLer. I was a contractor before that. You could ask, when did Mars 2020 land? And so now you could actually get a date, as opposed to lots of documents you could possibly go read in detail. You get an answer. Which missions went to Venus, and who's the project manager of Psyche. So even though this is something you can Google at the moment, it's not an easy thing to just ask that question at JPL, because our search doesn't do what Google does, right? So this is what we're moving toward. But it's very hard to get people at JPL to adopt new things, so we'll see how it goes. But we're hoping to integrate it into search. Our hope is that if you're a regular JPLer, you go to the search page, you put in a question, in the back end, it's going to talk to this, using the graph, leverage the graph in the background to get an answer, and then also give you results across the lab. So that's we have lots of ideal states. So before we go, or in other words, in conclusion, and we're going to do a little tag team here at the end.
So as you might have noticed from our technical nitty-gritty section, linking datasets does take effort. This is not something that just happens magically. It requires a lot of thinking ahead when you're creating URIs or making sure that datasets know about each other, can reference other URIs, or you're providing those hooks to make sure there's something to connect on. It requires data cleanup. We kind of made all of our scenarios look like the data is already in this nice RDF structured format. Obviously, that's not always the case. Even when it is, sometimes you have to go in and make sure you've got those hooks or you are reusing those URIs. And it requires what we call semantic momentum. For two semantic data sets to talk to each other, there have to be at least two semantic data sets. And the more data sets you have, the more willing people are to try semantic technologies and put their data in this format. So there are definitely some hurdles, but we think it's definitely worth it. We've been able to connect these data sets and build really robust knowledge graphs that then are powering things like Anne showed with that natural language search interface. And as you also might have noticed, because we spent a lot of time talking about URIs, URIs are very, very important to this. So we have some lessons learned for URIs. So one is establishing namespace owners for those different data sets, so you have a clear idea of who owns data and where that data is coming from. It's really helpful for governance. Another is to use what we call standard URIs from the get-go, so making sure that you're reusing URIs where possible and enables kind of that linking right away and enables federated queries. And then finally, reusing existing identifiers where possible. You don't want to recreate the wheel. If you're already using usernames or employee ID numbers, keep using those. It makes it easy for consumers to guess what URIs might be or matches their expectations. And it just makes it easier for maintenance and readability. Usernames are easy for humans to read, they're easy for machines to read, so it's a win-win. So.
And to finish up, knowledge graphs are awesome. See, I'm still very excited about them, and even more excited as our semantic verse grows. So we have built this semantic pyramid, and we're building upon it and leveraging different layers. And I think that enables us to link these multiple data sets and augment them and get better, richer data responses for it in order to answer questions. So that's us in this little rocket. It flies across the screen.
We have some time for some questions, so I'll have the mic. Oh, wow, a lot of questions.
Uh-oh.
Well, look, first, front row gets
Privilege of front row. I happen to live in La Cañada, California, so a big shout out to JPL for being a very positive force in our community. My 10-year-old daughter just took a field trip there yesterday, and she was beyond excited, like Frozen 2 excited. So. My question is about the use of the knowledge graph. I mean, you obviously talked about the search implication when I know that there's something that I'm looking for. Have you also gone through like iterations of sort of adjacent data that you could also tell me? Like if I'm looking for that room, you could also tell me that there's a lunchroom right next to it or something. Is that sort of part of like on-edge discovery? That's also part of your thinking that ultimately is the justification for the knowledge graph?
I know that there's an application on Lab called iMaps that does that very thing, where if you're looking up a certain location in a building, it actually calls it, of interest, things of interest around it. So it could be like the ATM or the cafeteria or whatever. So that application does that. And we actually use that application's data as a data source into the knowledge graph. But I don't think we're pulling in any of that adjacent information. But I know that when we're doing the testing for the natural language, somebody asked, where are the bike racks? So, well, maybe that's something else we should pull in to augment the facility information. So we keep growing, but that's a good idea.
All right,
Yes.
so you run the analysis of your internal data right now primarily, and these JPL people probably publish lots of articles in academic journals. Are you using any of these publications to track connections or find the field of expertise, or are you planning to
Yeah, that was one of our blue bubbles that we hadn't quite got to yet. But that is, we know, we've identified with these sources of that information, and so we're going to go after that soon as well.
Yeah, and we have done some small-scale proof of concepts on that, but it's not in our production knowledge graph yet. But definitely something we're very interested in.
Yeah, and we're hoping to really build out different taxonomies, both in science and engineering, so you could look up to see what that expertise is in. We need the taxonomies to really make it work. Yes.
Can you quantify, even roughly, the level of effort or resource investment it took to realize the institutional knowledge graph? Like, it took how many people, how long to build this?
Well, we have a project manager, but, so that's very, very small. There's me, there's Bess, and there's our Enterprise Semantic Platform people keeping the tools running, one of whom is here in the audience today. So that's the crew.
Yeah, I think it took us about 10 months from inception to rolling out the first version in production. We've iterated since then and added information. Call it a year, just to be safe, but that was with our tool sets already in place. So we weren't, that 10 months didn't include going out and finding the different tools we would need.
Somebody else over here had a question?
I use Protege for, modeling the ontology.
I'm interested if you have a mechanism for gathering feedback from your users and what that feedback has been.
Do we have I know the natural language tool has feedback mechanism. We haven't actually released that yet. I think we've been just reaching out to different groups around the lab, sort of like targeted conversations to see both data sources we can take advantage of and also what they can leverage from us. So it's been kind of a targeted approach.
And then we do also get good feedback from consuming applications. So we feed some data into JPL's enterprise search system. They'll get feedback about some of the search results, and if it turns out it's something that's coming from us, we'll get that feedback then through the applications. So that's been helpful. It's kind of indirect, but that's how a lot of users are actually interacting with the knowledge graph, is through some kind of third application that's consuming our data.
Yeah.
Thank you. My question is actually quite similar. Do you guys intend to build kind of a front end on this in terms of an individual profile? So post-search actually aggregating and normalizing that data per user, in which they can then either be kind of their own human in the loop to enrich and augment?
Well, we have what I talked about, what we want to do is with the natural language search plus search, incorporating that with search. Our graph database application also has a web-based interface, so people can go there and search for entities and visualize connections. If they know Sparkle, they can do queries. So there's that. And there's probably some middle layer that we would really like to have at some point, but that'll depend on resources and priorities, et cetera.
Right, but that is kind of the long-term dream, as we get into things like trying to connect people to expertise via publications. We would love to have some interface they could go in and say, no, I'm not an expert in robotics, where did you get this from? Or say like, yeah, endorse, like I am an expert in this field. So we definitely want to do that. It's not something we currently have.
Yeah.
Okay, unfortunately, we're out of time for questions, but one more question. Where is that robotics lab?
Where is that robotics
Can I
lab?
get a bicycle somewhere to get to it? No. All right, so another round of applause for our speakers here.
Thank you.
And I guess you can hang around a little bit if anybody else has any additional questions, but we have to end the session and move on to the next one. So
Right.
see
Thank
you
you.
in 15 minutes. We'll resume.